When 28,000 Python developers were asked which 3 features in Python do you like the most, the simple syntax ranked first, closely followed by the ease of writing and reading code. And in third position came in list comprehension and generators, with more than 20% of Python developers agreeing that those are the absolute best features in Python. We'll definitely cover generators in a separate video, but today we're interested in the list comprehension feature, a feature which in my opinion is the best example that showcases Python's beautiful and simple syntax that is both easy to write and read. Whenever I come across a feature that enables me to write in one line something that used to be written in multiple lines, more often than not I am skeptical about it, as I generally prefer the detailed and more expressive long version over short nerdy versions. List comprehensions can be easily categorized as one of those features that will enable you to write complex logic traditionally requiring multiple lines of code in a single line of code. And the reason I fell in love with it is because it completely destroyed my skepticism. In fact, by the end of this video, we'll see how we will replace all of this code with simply one line of code, all the while maintaining the readability of our code, if not even improving it in my opinion. Okay, so let's start off with a simple example to understand the syntax of list comprehension. And by the way, the goal of a list comprehension is to create a list. Actually, there are many types of comprehensions in Python that can create many data types such as dictionaries, but we'll keep those to later in the video. So let's take a look at the most basic form a list comprehension can take. Here we have a list nums, and we are setting result equal to, between square brackets, x for x in nums. So this list comprehension will simply copy this list into result. This part right here basically expresses what each element of this created list will be. Here we're saying that each element will be x. Who is x? Well, x will take on the value of each element within the list nums. So to better understand what actually happens here, let's write down the equivalent code without using list comprehension syntax. So first we'll have to create our new empty list results, which will be populated as we iterate over our loop right here for x in nums. Then, for each of these x's, we will simply append the values as is without any modifications to our newly created list. And running this code, we can see how both approaches output the same exact result. Going over this part right here once again, this is actually what we call the expression, which will be evaluated in the context defined afterwards. So here, for x in nums is our context within which we will evaluate this expression, which is for now just x. If, for example, we write down y for x in nums, running this code we will get a name error stating that y is not defined, because in this context right here, for x in nums, there is no mention or declaration whatsoever of a variable named y. Now this part, the expression, can actually be set to any valid Python expression. Say we want to compute the square of each element of nums and store those in result. We can simply write down x to the power of 2 here, which is equivalent to writing x to the power of 2 here in this equivalent code, and here you go. We could also define our own function, for example, and store within result the returned value of myfunc of x for each x in nums. So we can already start to see the power of list comprehensions and how it makes it much easier and cleaner to define new lists in our code. In these examples, we saw how to transform a list into a new one by defining various expressions at each element. What we can also do is filter out the elements of a list by specifying a condition right after the for loop. For instance, let's revert our expression back to x for simplicity, and now we'll add after our for loop if x greater than 2. What this will do is filter out our elements and only evaluate and append this expression if the condition is true at each iteration. Running this code, we can verify that all elements not satisfying this condition were successfully filtered out. So this will be 100% equivalent to wrapping our append of x here with an if statement with the same condition. Isn't that already awesome? Instead of 4 lines of code, we were able to cleanly and expressively write our logic in a single line of code. But wait, it gets even better. Technically, a list comprehension has to start with an expression followed by a for loop, and after that, you could write down as many for loops or if statements as needed. But careful not to get very excited or else you lose the charm and readability of list comprehensions. So I would personally limit myself to a maximum of 2 for loops per list comprehension for readability. Here's an example where 2 for loops are used within a single list comprehension. Combinations is equal to, between square brackets, the tuple x, y. Who are x and y? Well, x is each value in the list 1, 2, 3, and then for each of these x's, we loop for y in the list a, b, c. Printing the result, we can see how we successfully generated all possible combinations between the two lists. So we have the tuple 1a, then 1b and 1c, followed by 2a and so on. If you're wondering why did we get such a result, or maybe you thought we'll just get the tuples 1a, 2b and 3c, don't forget that here we're effectively nesting the for loops. So this would be equivalent to the following code, in which the loop on the y values is nested within the loop on the x values. So for each of these x's, we loop over all the values of y. If instead your goal was to actually just generate the tuples 1a, 2b and 3c, for that a single for loop is enough, where we loop on both lists simultaneously using zip. If you're not familiar with zip, I would highly encourage you to watch my super quick short video on the topic linked in the description below. I regularly upload short videos that quickly explains various Python topics in less than 60 seconds, so it's an amazing way to improve your Python seamlessly. Going back to our nested for loop situation, I wanted to quickly mention something important when chaining such for loops and ifs in a list comprehension. Even though the expression is what we write at the very beginning of our list comprehension, don't let that fool you as to the hierarchy and order of the context that follows. Here, the order is always from left to right. So the for loop over x will come first, within which the for loop over y will take place as we've seen here. To further prove that, say we want to filter out tuples where y is equal to c. First off, if we put our if condition right after our expression, that's already a syntax error and we're not allowed to do that, as after the expression, a for loop must be written. Now, if we move our if condition to after our first for loop, at least now we don't have a syntax error, but we nevertheless get prompted with an unbound local error, stating that we're basically using y before even assigning it, proving that by this point, y is not yet defined. Finally, we'll have to move our if condition until after the y for loop, and only then would it have context of what is y and be able to run the code successfully. And we can verify that all tuples where y is equal to c are filtered out. There's one last very cool thing I want to mention in list comprehension before moving to other types of comprehensions. Say we have a list containing 3 lists, where each sublist contains some integer values. Let's suppose our goal is to remove all negative values. How would we do that? Let's start thinking about how to write this logic using the list comprehension syntax. We will write down filtered data equal to, between square brackets, some expression here that we'll think of later, but for sure we want to loop over the sublists of the data list so that we can process them. So we will write for sublist in data. Now, what about the expression? What do we want to do with each sublist? Well, we want to remove its negative elements. So technically, we want to filter out its elements based on a certain criteria, which is something that list comprehension allows us to do very eloquently. So here, for our expression, we will actually use a list comprehension. And yes, there's nothing keeping you from nesting list comprehensions. Hence, we will write a list comprehension assuming that we have access to a list called sublist. To do this filtering, it's very simple. Between square brackets, x for x in sublist, and now for our filtering criteria, if x is greater than or equal to 0. So now for each sublist, the following expression will be evaluated, and the returned list is the thing that will make its way into our final filtered data list. Isn't that just awesome? If we were to write this logic without using list comprehensions, the code would have looked like this. 7 lines of code to do the exact thing we did in a single line of code. Tell me that isn't satisfying. And I would personally argue that the list comprehension version, even though way smaller, is still cleaner and more readable than the longer version. Feel free to pause the video and go over every line in this code to make sure you understand it, as this is exactly what the list comprehension is actually doing under the hood. But for now, let's move on to the final topic of this video, and that is the other types of comprehensions you can write in Python. So for now, we've only seen list comprehensions, which are these expressions evaluated in the context that follows with everything enclosed between square brackets. The same square brackets used when defining a list. Well, by simply replacing our square brackets with curly brackets, we will effectively be writing a set comprehension, which, as you guessed it, produces a set. Now, what if we wanted instead to generate a dictionary using this syntax? Turns out it's quite simple as well. We already have curly brackets here, so that's great, but now, instead of just providing one value for each element, we will have to specify a key colon value for Python to be able to differentiate and understand that this is a dictionary comprehension rather than a set comprehension. And here you go, we generated a dictionary with integers as keys and their corresponding squares as values. Finally, let's go back to our original code, and now we will replace our square brackets with parentheses. Despite what you might guess, this will not be considered a tuple comprehension, as there is no such thing in Python. But rather, this will be a generator comprehension, or more frequently referred to as a generator expression. Think of it as doing exactly the same thing as a list comprehension, but instead of performing all calculations and storing all the results in a list in memory, what this does is evaluate each expression one element at a time whenever it is requested, and never store any result in memory, which is awesome when you're dealing with very large data. If you recall the beginning of this video, I mentioned that generators are also one of the most beloved features in Python, and this topic deserves a video on its own, where we dive into the details of how generators work in Python. So make sure to subscribe and activate the bell button to be notified when I upload the generators video. I really hope you enjoyed this video and would like to commend you for making it this far. Don't hesitate to replay any unclear section, and please leave your comments and questions below. And as always, don't forget to like if you want to learn even more Python.